I thought I'd do one more video and just explain a bit more about the directory, which is the heart of the CP/M operating system. When Gary Kildall wrote this operating system, this was one piece of code that is really interesting, just the way this works. I've written a disk editor program that I'll show you that allows me to inspect the disk and see what's going on inside of the directory. It's been an interesting experiment. Just as a review on the file system for my 8080 computer, at the bottom on track 0, you can see we've got the CP/M image. I've allocated sectors 0 and 1 for potentially an on-disk bootloader. May not use it, might use it, don't know. Just went ahead and reserved it just in case. But then the rest of that track is used for the CP/M image. That's what I actually boot from. My boot code is in the monitor. Disk allocation blocks actually begin at the directory with allocation block 0. So this is on track 1. So track 1 is going to be my directory. Blocks 0 through 7 are reserved for the directory. Above that starts allocation block 8. That's where my files go, and that will go up all the way to allocation block 2039. And you can see it ends at track 255. So just as a review, track and sector and CP/M are always offset 0. They start at 0 and they move up from there. Versus offset 1, you see in a lot of other machines, different controllers, their disk controllers will start with sector offset 1. But in my case, we start with sector offset 0 for both track and sector. Allocation blocks are also offset 0. Your first allocation block is going to be 0 and not 1. My block size, the block size I chose for my computer is 4096. That's turning out to be a pretty decent choice, so I'm just going to leave it at 4096. Each allocation block holds 32 sectors. I can get 32 sectors inside of a single allocation block. Track 0, Sector 0, and Track 0, Sector 1, as I mentioned earlier, are reserved for the CP/M on-disk bootloader. Might use that in the future, might not. Track 0, Sectors 2 through 255 are reserved for the CP/M memory image. Track 1, allocation blocks 0 through 7 are reserved for the directory. Allocation blocks 8 through 2039 contain user files. So a little bit about this directory. A directory is actually 32 bytes long. 16 bytes you see at the top and 16 bytes at the bottom. The 16 bytes at the top are broken up with 1 byte as a user number, 8 bytes as a file name, 3 bytes as an extension, of which the high bits are used to indicate the file attributes like read-only, sys, or whether the file's been archived or not. And then a byte for the extent number. It only uses the first 4 bits. And we'll talk about what an extent is in a minute. And then the next byte is reserved. After that is a continuation of the extent number, the most significant bits. There's 5 of those. And the last byte is the number of sectors used in this extent, in this directory entry. Below that are 16 bytes that are used for the allocation blocks assigned to this directory entry, or this extent. So if you were to look at a directory entry on my machine, a directory containing myfile.txt would have a 0 in front of it. I do everything with user 0, but you have 15 users that you can also add. There's myfile, the 8 bytes that are used for the file name, and then 3 bytes for the extension. And then because this is the first extent, this is the first directory entry, there's going to be a 0 in the LSB and a 0 in the MSB bytes. And then 7E just indicates how many sectors have been used in this extent, this directory entry. Notice that all the bytes for allocation blocks have been filled in. So this is a fairly large file. But what happens if you need to continue writing into this myfile.txt file and you run out of these application blocks? You're all the way over here at block 53 stored in this last byte. What happens after that? Well, what CP/M does, it will open up a second extent. The flag for the first extent being full is this 80. If you see a 80 in this byte right here, that indicates this extent is full. So it'll create a second extent, and notice that it's identical. Say user 0, my file at text, so the file name and extension are the same. The thing that's changed is this right here. So this was extent 0, and we've opened up a second extent. This is extent 1. And then after that, I'll continue counting the sectors used for this extent. Now, if you remember when we were talking about disk parameters, there's one entry in that disk parameters block that affects how the directory looks, the EXM. So if you have less than 256 blocks in your file system, then this is going to work out really well, because 1 byte can reference up to 256 allocation blocks. But what if you have more than that? What if you have more than 256 blocks in your file system? Well, you have to put a 1 here in this EXM. When you do that, what that does to the directory is change it. Instead of having 16 1-byte entries, you now have 8 2-byte entries. So just keep in mind, first byte is user number. After that is 8 bytes for file name, 3 bytes for extension, and then there's extents. So this is the directory entry for a file that has 8 allocation blocks in it. If you need more allocation blocks, then you create another entry. We create another extent and start counting out from there. Let's see what it really looks like in a real file system. I'm connected to my machine with TerraTurn. Let's do a directory. These are the files. One of the files I want to look at is disk edit. So I'm going to run this program and show you what happens. This program I've written for my CPM machine could potentially be used on any CPM machine, but it would need to be modified for the file system that's on that machine. This one is built specifically for the file systems that I have on my machine. I can change disk drives by pressing the D key. So I can change to, let's say, drive B. I can change to drive C, and so on. I'm going to change to drive A again. And then I can change tracks. I can press the track number, and I can put in track 1. Track 0 is my boot track, and track 1 is my directory track. And then I can change sector numbers as well. Pressing the S key, I can change to sector 1. And then I can use the arrow keys up and down. So I can, arrowing up allows me to move up through the sector count. And then pressing the arrow down key allows me to go down in sector count. Pressing the right key allows me to go up in track numbers. And then pressing the left arrow key allows me to go down in track numbers. Another thing that's useful is being able to enter in a block number. So I'm going to type in B and then block number 8. That automatically takes me to track 2, sector 0, which is the location of block 8. And then from there, you'll notice relative sector, that is sector 2 of block 8. And then you can trace that back to the actual track and sector number. And when I get to sector 1F, and if I move up 1 sector, notice what happens to rel sector. It goes to 0 because we changed to block 9, and now we're on sector 0 of block 9, which just happens to be track 2, sector 20. The home key takes me back to the track 0, sector 0. But another nice feature is being able to edit. And I can now edit this sector. The arrow keys allow me to move up and down in this sector. And when I see something I want to change, I can just enter in the bytes as I want them to be, enter the bytes that as I want them to be changed to. Once I've got the sector edited, then I can do a Control S to save it. and then a Control R to reload it just to check that the changes have been made, and they have. You can also just put that back the way it was. Great. Let's take a look at what's on drive G. Drive G. And let's change to track 1. So track 1 contains nothing but E5s. E5 is the indicator to CPM that the directory is not used. So right now, G has no files as far as the directory is concerned. Let's Control X that and check. Control X. Let's go to G. No files. Let's create a file in drive G. And I'm going to insert a line. There we go. Control Z. E ends the editing session. And now let's see what we've got. We've got a backup file, which should contain nothing. And then we've got our test.txt file, which should contain the text we typed up above. Let's find out. And it does. There we go. Contains nothing. Now let's use diskEdit. And I want to go to track 1. Here we go. So notice I'm now looking at the directory. This was the first byte. That's the user number. That should be 0. That's me. And then I got a second file in here, test.txt. That's got user number 0. That's also me. These 1, 2, 3, 4, 5, 6, 7, 8. There's your file name. And 3 bytes, there's the extension. This is the extent number. It should be a 0. Expecting that to be a 0 for both files. Test.back had nothing in it. So it's not unusual that this contains a 0. Notice that the allocation blocks down here, this line, there's no block allocated to this file. It's completely empty. Whereas test.txt has 1 sector. But notice that over down here, allocation block is 8. This is where the data starts. Well, let's take a look at allocation block 8. I'm going to go change the block number. There it is. So there's my text, carriage return line feed. There's more text, carriage return line feed. And then there's the end of file markers that are filling the rest of the empty space in this sector. Nice. Let's erase test.txt and see what happens. There we go. So my allocation block size is 4K. And this directory doesn't look at how many sectors are used. It just reports how many blocks are used. So it says test.txt uses 4K, even though it's only a couple of lines. But let's erase it. So all we got is test.back. Now let's run diskEdit again. Change to track 1. There we go. So test.txt has an E5 right here. That's the indicator that this file has been erased. It can now be used by another file. So if you create another file, it's more likely going to get this entry. But however, block 8 is still in the entry. This is what indicates it's not going to show up in a directory list. Let's look at block 8. Our data is still there. So folks that remember working with DOS in the old days, This is exactly the same thing. If you erased a file in DOS, it would put a special character in the directory name, but all of the allocation blocks were the same. It didn't actually erase the data on the disk. It just flagged the directory so that you wouldn't see it in a directory list anymore. One of the things we can do is we can change that. So let's edit this directory and find out if we can bring this file back. I'm going to change to navigation mode, and then I'm going to move to track 1, and then I want to edit this, Control E, and I want to change that to a 0, 0, and then I want to save it. Now let's exit Disk Editor and do a directory. Our test.txt file is back now. Let's list it. And it has all of the same data. So there were folks in the DOS days, I think Norton Utilities was one of them, that sold these unerased programs. And what these unerased programs would do is they would walk through the directory looking for erased files, and then as much as possible, they would try to reassemble the blockchain and get your files back, get your data back. And if you erased a file and stopped immediately and ran the unerased program, you had a very high likelihood that you could recover that file. The same thing with CP/M. The big difference between DOS and CP/M is that CP/M, the directory entries, contain the file allocation. So this blockchain is in the directory. What DOS did was break that out. You had file allocation table, that was the chain of used blocks, and then the directory would point you to this chain of used blocks. And you do the exact same thing that CP/M does that in DOS. It just reassemble the chain so that you can retrieve the sectors that contain the data that you're looking for. Let's do a really big file. Before I do that, I'm going to return this file system to its formatted state. There we go. Now it's formatted. Track 1, the directory track, nothing but E5s. So this is now ready for files. Directory shows nothing. So what I'm going to do is transfer a bigger file. Let's do this. Let's move over a large file. I'll move over diskedit.asm, the file I use to create diskedit.com. File, transfer, xmodem, send, diskedit.asm. Now this file is large enough to create a couple of extents, and so we'll be able to then look and see what this extent stuff looks like. All done. Directory, diskedit.asm. Let's do change to track 1. Now notice we've got 2 directory entries for diskedit.asm. Check out the extent numbers. So extent 1 contains these blocks. You can see that this extent is full. And one of the ways you'll know it's full is if it's got an 80 in it. So this one's full. These are all the blocks that are used. And then the second entry, this is extent number 2. And then here's the blocks that are used for it. Stops at block 13. Let's take a look at block 8. Yep, that's the beginning of the file. Yeah, it's all there. Let's change to sector 00. There we go. You can see how the directory in this file system works to keep allocation blocks associated with file names so that you can then retrieve these allocation blocks and look at the file. Well, I thought that was really, really very interesting, and I wanted to share it with you. And that's the reason I created this extra video in the series. And I hope you enjoyed it, and I hope to be presenting again soon.